Okay, so we have done the kind of like application portion of this unit, which is like exponential growth, exponential decay. We talked about compound and simple interest. Now we're going to be doing the graphing portion. So today and tomorrow we're just going to talk about properties of exponential functions, and then tomorrow we'll talk about transformations of exponential functions. So if I go to graph any kind of exponential function, and I'm not sure what it looks like, or I'm not quite sure how to do that, I can always just create a table of values. I can choose some x's and I can plug them into my equation and I can find some y's. And that should give me a spread of points that I can use. And if you find that you don't have enough, you can always add on a few more x's toward the negative end and toward the positive end to get a good graph. So we're going to start by taking these x's over here, and we're going to start plugging them into the equation for x and calculating what we get for y. Okay, remember to follow BEDMAS rules here. Okay, if you still have a phone on your desk, that needs to go away, please. Okay, so everybody needs some calculators. Let's start calculating by plugging in our x's. Okay, what'd you guys get for the first one? 16, yep. For -1, 8, good. I think 0, we get 1 for the half to the exponent 0 times 4, which is 4. One. Someone say 0. What do we get? Yeah, we get 2 for 1. And then for 2, I think we get 1. 3, we get a half. And 4, we get a quarter. Okay, so I think that we are going to have to go by 2's on here in order to fit this point, -2, 16. So on the y-axis, I'm going to go by 2's. On the x-axis, I'm just going to go by 1's. So we'll do 2, 4, 6, 8, 10, 12, 14, and 16. And then 1, 2, 3, 4, 5, and so on the x-axis. Okay, and then we're just going to start plotting our points here. So 2, 16, -1, 8, 0, 4, 1, 2, 2, 1, and then we're getting some pretty small points here, getting close to our x-axis, but not quite touching our x-axis. Now, I think we talked about this a little bit before, but if I continually half something, does it ever reach 0, technically? No, it's just going to get smaller and smaller and smaller and smaller if I keep halving it. So we talked about how these functions have horizontal asymptotes along the axis here. So we'll also pencil that in as well with a different color. And our graph should approach that line but not cross it and not touch it. Okay, so this is what our graph looks like. So we're going to explore a couple properties of this. Domain. So domain, if we look toward the right here, so remember domain is the horizontal. It's the x's that our function can have, and range is our vertical. Do we have any right boundary on this function? Is it ever going to stop going toward the right? How about left boundary? Is this ever going to stop going this way? No. There's also are there any restrictions on what I can enter into this exponent for x? I think I can enter in anything, right? It can be a decimal, it could be negative, it could be 0, it could be positive. So our domain is everything, all real numbers. Okay, just as a little hint for you, every exponential function has a domain of all real numbers. Okay, range is a little bit different based on what function we're looking at. So when we look at the y's here, we notice that there aren't any negative y's. And also I can't touch this asymptote. So how do I say what y can be for the range? Bonnie? Yeah, so y must be greater than 0. Yep, good. So we're going to have, y is an element of real numbers where such that y must be greater than 0. Okay, I'm not putting greater than or equal to 0 because it actually can't touch 0. At 0, we have an asymptote. So essentially what this is saying when I say y is greater than 0, we're saying y is all positive numbers. Okay, x-intercept. What's the x-intercept? Essay? Right, so there's no x-intercept. So we'll say none for that one. There's an asymptote on the x-axis. What about y-intercept? Do we have one of those? No, it doesn't cross the y-axis. Alex? Yep, so it's at the point 0, 4. Good. Okay, this is something new, intervals of increase, decrease. So the little test that I like to do is when I'm looking for intervals of increase, this is saying over what x values are the y values increasing or decreasing. The thing that you can do to test whether it's increasing or decreasing is start at the left side of the graph with your pen or pencil and just trace along the graph. And if your hand is going up, it's increasing. If your hand is moving down, it's decreasing. So we're going to trace our pencil left to right. I just spelled 2 backwards. Why did I do that? No, and it's not letting me erase. There we go. Okay, trace your pencil left to right. If your pencil is moving up, that means that's increasing. If your pencil moves down, your function is decreasing. Sorry for the messiness here. Okay, so we're going to trace our pencil left to right. If your pencil is moving up, the function is increasing. If your pencil moves down, your function is decreasing. Okay, so some functions can have increasing parts and decreasing parts. Like if I think about quadratic, my quadratic has a section, let's just say like a regular quadratic. It has a section that is decreasing as I trace left to right. And then it starts increasing, right? Because it goes down and then it goes back up. Exponential functions are usually one or the other. It's either always increasing or always decreasing. So again, it's asking for what x values are the y values increasing and for what x values are the y values decreasing. So if we look at this function here that we have, as we trace our pencil left to right, is our pencil moving up or is it moving down? It's down. So this function, does it change direction anytime? Like is it going to start going up eventually here? No, it's going to keep going down. So it's actually decreasing everywhere. Okay? Essay? So the y's are decreasing over the x's as the x's move forward. Yeah. Okay, so this function has no intervals of increase. We agreed that it's decreasing everywhere. So none for increasing. And if it's decreasing everywhere, we say for all x's, the y values are decreasing. So we're just going to say, kind of like we say in domain, we're going to say for all x's, or for all real numbers of x, the graph is decreasing, or the y values is what we're talking about. Y values are decreasing. Okay, and then we already said above that the asymptote is on y equals 0.
Is there one for x? Asymptote?
No. These ones just have a horizontal asymptote. Can I scroll? We're all good? Okay. Okay, we're going to graph one more function and take a look at some of its properties as well. So one little note here, we need to remember that the exponent on a value only applies to what's directly in front of it. So is negative 3 being raised to the exponent negative x, or just the 3 part of that being raised to the exponent of negative x? Just the 3 part. So when I do my calculations, I want to think of this negative as if it's negative 1. And then the 3 will be to the exponent negative x. Also, I need to keep in mind that if I enter in something like negative 2, what happens if there's already a negative there? It becomes positive 2, right? So if I'm entering in a negative value in for x, it will actually become positive because it already has that negative there. Okay, so let's start entering those x values into our function. What'd you guys get for the first one? Yep, you should get negative 9. Good. So the negative 2 becomes positive 2. So we're really doing 3 squared and then times negative 1. So we get negative 9. Joey?
Do I have to put the negative 1 bracket 3?
You don't, no. Your calculator should know that it only applies to the 3. Did you have a question?
Yeah, it was just about, like, how come you put the negative 1 in front?
So the exponents only apply to what's directly in front of them. Like if I wrote negative 2 squared, it's actually 2 squared, and then the negative is not being squared. The negative is like a negative 1 that has an exponent 1. So the negative is actually not included with the exponent. You don't have to write negative 1 though. Okay, what'd you guys get for the next one? Negative 3. And for 0, I think we get negative 1. And then it's negative 1/3, and is that right? And then negative 1/9. Okay. So I think we can go by ones on our y-axis this time. And I'm going to go by ones on the x-axis as well. And then we'll start graphing our points. Actually. Okay, so negative 2, negative 9, negative 1, negative 3, 0, negative 1, 1, negative 1/3, and then we've got negative 1/9, which will be pretty close to the x-axis there. Hey.
Can I have any chance to leave my pencil, please?
Yeah, I think it's right there on the desk.
Thank you.
Yep, no problem. Okay, so I think if we connect the points here, it looks like it's going up, and then we have that asymptote again along y equals 0, so it kind of approaches that asymptote, which happens to be the x-axis in this case, but it won't touch or cross over this line, so y equals 0. Okay, if you're not like 100% sure what happens after the value 2, you can always add like 3, 4, and 5 onto your graph here, your table of values, and then add it onto your graph just to see what's happening. But I think the general trend is that this is being cut by a factor. It's being divided by 3 to get our future values for y. So I think 3 will be like -1 over 27, and so on. We'll just keep dividing by 3. Okay, so domain, again for this, I'm going toward the right forever and also toward the left forever. There's no x's that I can't enter into my function. It's all real numbers. Okay, like I said, this is going to be the case for all of our basic exponential functions, or all exponential functions, I should say. Okay, range is changing based on what is going on with our function. So can somebody create an expression for range for us for this one? Derek? Okay, so we'll say y is an element of real numbers such that y must be less than 0. So it doesn't touch 0, but it's all the negative values below that. So it must be smaller than 0. Okay, do we have an x-intercept this time? No, we don't. Okay, there's still an asymptote on the x-axis. So for x-intercept, we will say none. Do we have a y-intercept? What is it? Okay, so we'll say it's the point 0, -1. Intervals of increase, decrease. Okay, so this function is increasing. Oops. I don't know if my eraser, oh, my eraser works now. Nice. So as we trace left to right here, we can see that our arm is moving upward. That means that my function is increasing. I don't have an interval of decrease, okay, because it's just going up for the entire function. So for decrease, we will say none. And for increase, we'll say it's increasing for, the y's are increasing for all x values. So we're just going to say x is an element of real numbers. Okay, and then the asymptote is the same as the one before. It's y equals 0. Okay, for our purposes today, all of the asymptotes are going to be y equals 0. When we start working with transformations tomorrow, anytime there is a c value shift, it will shift our horizontal asymptote up and down with that c value shift. But for now, for any basic exponential function, you will see that the asymptote falls along that y equals 0 line, along the x-axis. Okay, any questions on this one? We're good? Okay. All right, so we have gone from equation to graph. Now we want to see what we can do from graph to equation. So when I'm trying to figure out the equation of a basic exponential function, I am working with this equation, just like we worked with for our applications. And my job is to fill in A and to fill in B. Okay, so if we look back at the two graphs that we just graphed, I want you to look at this equation right here. So this equation, -1, what do you notice that relates to on my graph down here? Not the asymptote. The y-intercept. Is that true for the first function as well? Does the y-intercept match that a value out front? Here the a value is 4. Is the y-intercept 4? Yes, it is. So as long as there's no other transformations, my a value should actually be my y-intercept. And my b value is kind of like what's happening to my y's, like it's a constant multiple. So there's only one little problem, and that is that I can't actually exactly see what that y-intercept is because it doesn't cross like on an actual like cross section. So maybe what we'll do is we'll just look at a table of values here, and I'm going to leave a little space so that I can maybe figure out what the y-intercept is in a second. But if I can maybe find what y values are for 1, 2, and 3, maybe I can reverse the pattern to go backwards for when x is 0 at the y-intercept. So at the point 1, we have a y value of 6. At the point 2, we have a y value of 18. And at the point 3, this one's a little tough to see, but it actually crosses at 54. Okay, so the b value, what I'm looking for is I'm looking to see if there is a constant multiple by which all the y values are changing by. Is there something that I could multiply each of these by consistently? Yep. So if I multiply by 3, I'm actually going to get my future y values. So that's actually my b value. So we can put that in for b. I still need the a value, or the y-intercept. So if this is going by 1s, if I go back 1, how could I get that number from 6? Divide by 3. So what does that give me for the y-intercept? 2. So at a time of 0, my initial value is 2, essentially is what we're saying, right? Or at an x value of 0, my y value is 2. That is the a value. Good. If you're not sure if your equation is right, I can do a quick little check. I can sub in 1, 2, and 3 for x and just make sure I'm getting the proper y values. I should get out 6, 18, and 54 if my equation is correct. Okay, so this is b, and then our a is like the y-intercept. Okay, this is only true if you don't have any other like transformations, like shifts or other things going on in your graph. So it's just for basic functions that have like an a, b value. Once we get into transformations tomorrow, you'll notice that the y-intercept changes if we have shifts and stuff like that. Any questions for this one? All good? Okay. All right, we're almost done. Okay, so this is just like a little summary of the 4 different types of shapes that your exponential graph can take on. So either it is growth. Okay, so this first one here is the graph of like growth. And when your a value is positive, that means that it's growth above the asymptote. So it's increasing toward the right. And it still has that asymptote along y equals 0, unless it has like a shift or whatever. But for our purposes today, we're just going to have all of the asymptotes along y equals 0. And this happens, so we know growth happens when b is greater than 1. So when b is greater than 1, like 2, we have something like doubling happening, right, which is growth. Now when b is between 0 and 1, something like a half, we have those like half-life type questions that we were talking about, and that's the graph of decay. And that also has the asymptote along y equals 0. But they're above the asymptote because the a value is positive. Okay, so this means the a value is positive when we say greater than 0. Okay, so a sample equation that would produce this type of graph, so increasing above the x-axis, or above the asymptote, I should say, could be something, so any positive a value, so let's say 3, and any b value that is greater than 1. So Kendall, can you give me a b value that's bigger than 1? 3, sure. So 3 to the x. So this type of thing, positive a value and b value bigger than 1, would give us that shape. This one over here would have to have a positive a value. So suppose maybe we have the same a value, but the b value has to be between 0 and 1. Tamala, can you give me a b value between 0 and 1?
0.5.
Sure, or a half, right? Perfect. Okay, and this right here, because the a is positive, it's still going to be above the asymptote, but because the b is now decay, it's like half-life, we have a graph that's decreasing toward the right. Now the ones on the back, if you imagine if we make our a values here negative, what's going to happen is those graphs are just going to flip vertically. So the 2 on the back, they're not a memorized thing, you don't have to memorize them, but if the a value is negative and we have a b value that is growth, like 2 or 3 or 1.5, then it just flips down, okay? And then same idea here. If the a now becomes negative and b is still between 0 and 1, this graph flips down like this. Marianne? Positive. I just put like plus with a VE to say positive. Like positive, like plusative. I don't know. You get it. Joey?
So if you flip that one, it'll become increasing, right?
Yes. Yeah, it'll flip like this. Yeah, so it changes, like when we flip it, it changes from decreasing to increasing. So that would be these two graphs. So the only thing that's different here is that instead of the a value being positive, now it's negative. Is that okay, Marianne? Yeah. Negative, okay. And this one will also be negative. Okay, so asymptotes are still there, but it's kind of like this growth graph has been flipped upside down. Okay? So that's kind of the idea. So you don't have to necessarily memorize this kind of like summary, but just understand like, okay, here's the graph of growth, what growth looks like, and then when a is negative, it gets flipped. And then same idea, when I have the graph of decay, when b is between 0 and 1, and a is negative instead of positive, it gets flipped vertically. So now it's an increasing graph. Okay? And we still have that asymptote along y equals 0. Okay, so some sample equations could be possibly the same equations that we had on the last page, but just with negative a values. So for example, we would have negative 3 and then 3 to the x. So just changing that equation in the first one to have a negative a value. And then an example of this one could be, what did I have for the a value up here? 3 again? Oh yeah, okay, so a would be like negative 3 and b would be still a half. Okay, so they're just flipped versions of the graphs above. Okay, so we're gonna do some really quick sketches. I'm not gonna make you do like a whole table of values for the next few. So we're gonna do them really fast. We're gonna plot the y-intercept, which we know if there's no extra transformation and it's just an a, b to the x, is equal to the a value. We'll plot the asymptote and then we'll decide on the curve of the graph. Okay, so it should be really, really fast. Okay, so a is positive. That tells me I either have growth above the asymptote or decay. Which one is this based on the b value? Decay, decay. Yeah, so I should have something that is curving down toward the right. I have an asymptote, like we said, along y equals 0. What's my y-intercept? The y-intercept is 2 because the a value is 2. So crossing at the value 2, and we said it's decay because b is between 0 and 1. So it must be curving like so. Okay, so we know positive means above the asymptote, and this is between 0 and 1, so it's decay. Good? So if I ask you for a really basic sketch, you'll plot your y-intercept for me, show me where the asymptote is, and then show me the shape that the graph takes on. If I ask you for like a full graph with transformations, then you'll use a few more points. Any questions for this one? Okay, let's try another one. Again, should be really quick. Okay, so I have a positive a value. That tells me that it's up above the asymptote here, and it's either growth or it's decay. Which one is it? Is it growth? Yeah. Why do we know that it's growth? Not over 0, but over 1. B is greater than 1. That means growth. What's my y-intercept? 2. Yes, because the a value is 2. So we have something like this. Again, these are really general sketches. And we'll pencil in our asymptote as well. Okay, so this means growth. Good? Okay, 2 more quick ones. Can I scroll? We're all good? Okay. All right, now A is negative. And B is greater than 1. So this is actually growth that has been vertically flipped because of this negative value right here. So if I have something like this, and imagine it gets flipped vertically, I now have something that takes on this shape. Okay, that's what my sketch should look like. Where should my graph be crossing the y-axis? At -2. So I should have a point right here. So we'll just adjust our graph a little bit. I'm going to erase that. And we have this. So -2 and y equals 0.
Is that okay?
Yeah, I thought that was okay.
It should be,
Because it's going down.
if you're tracing it, it goes down.
So when b is greater than 1, though, it's growth, but the a value flips it. So it's like growth that gets flipped vertically. So it becomes a decreasing function.
So if it has a negative a,
Yeah.
then that means it's going to be the opposite.
Okay, so what happens when we have a flipped graph of growth is the graph becomes a decreasing graph. And it's underneath the asymptote this time rather than above. So that's what happens.
Would you call that decay or just decreasing?
Yeah, we could call that a type of decay. Usually, like, when we're working with like growth and decay questions, they're always going to be the versions of the graph that are above the asymptote anyways. So I would more refer to this as a decreasing graph rather than decay. Okay, and then the last one here, we have a negative a value. Okay, that tells me that it's below the asymptote here. And I have a b value between 0 and 1, which tells me that we have decay. So it's kind of like this graph of decay gets flipped vertically. So I'm going to have something like this. Where should this graph cross the y-axis? At -2. Okay, so we have a point here. And I'll just erase that so we can get a better graph. So probably something like this. And then I have the asymptote. And I'm just going to label the value of the y-intercept. Okay, so what happens when I have a negative a value and a decay? It gets flipped and it becomes an increasing graph. So it's increasing below the asymptote. Joy?
We're not supposed to sketches on a test. Do we have to write all that stuff on the left side?
I would just look for your y-intercept to be labeled, your asymptote's location, and the correct shape of the graph. Those are the 3 things that I'd be looking for. Good? Any questions? Okay. Pause this, or stop it rather.